All right, let's get started. Welcome everybody. Welcome to this next edition of Startup Academy. So I'm going to be the host for this morning. My name is Jason Forte. I'm a solutions architect for startups, and I'm based in the UK. Today's session, we are going to be tackling a very interesting topic, one that I'm quite passionate about, and that is containers. And more specifically, we're going to learn a little bit about Elastic Container Service, or ECS, and specifically how you can run containers at scale using the power of AWS Fargate, which is a serverless runtime environment for containers. But before we get into the content, I just want to shout out to the partner who's joining us today. We're joined by Firemind. We'll do a little bit of introduction to who Firemind are and what they do in a little bit later. Before we go into that, I just want to tell you a little bit about Startup Academy and what we're trying to do. So the idea of Startup Academy is that we want to provide startups with a on-demand learning facility to be able to learn about new products and services and how to build on AWS. Basically, these are both business and technical sessions. So you'll be learning in this session about the technical side, like ECS, but on the business side, we also have sessions on things like how to prepare a pitch deck, how to hire, those kind of things. And what we really want to do is give you all of the kind of knowledge you need to get started building, launching, and growing and scaling your company using the power of AWS. The other thing is that these are live. I am actually here in my room, and I am actually doing this on this Thursday morning, this early. So feel free to ask questions during the session, and we will do a live Q&A at the end of it once we've gone through the content. Right, so for the intro for Firemind, I just want to invite Ahmed, who's going to be representing Firemind for this session. Ahmed, if you want to just come on camera and come on voice and just give us a little bit of an introduction to what Firemind do and yeah, just who they are.
Thank you, Jason. So yeah, I'm Ahmed. I'm MD here at Firemind. We are an AWS Advanced partner. We help startups scale, specifically around data, ML, AI, cloud native. And that includes things like containers, serverless, making sure their engineering team are using correct CI/CD. And what we offer as well is something called a Basecamp offering that AWS fund, where we can come and sit with startups. We can help them understand what they need to do if they're journeying into the cloud or they're already on the cloud and what they can do better, etc. And it's all about thinking, what does that product roadmap look like? What can we achieve within the next 3, 6, 9 months, and how we can really help you accelerate everything that you want to do on AWS to then get to the next bit of your organization, whether that's funding or more users or whatever you want to achieve. So that's us.
Thanks so much. Cool, you can go off camera and I'll introduce from the AWS side. We have Iulian, who will be directing the sort of core part of the content. The way that it's going to work is Iulian will do a little bit of an introduction to AWS Fargate, some of the different components of it. And then at the end, Ahmed's going to give us a demo of something that he's built using ECS and using Fargate. That's quite an interesting demo. So it's a little like, well, I'll leave it till the end so that you can see what it is. In the meantime, please do ask questions, whatever comes to mind. We do have a couple of moderators in the background who can potentially answer any other questions that you might have. And some of the questions we'll just pick and we'll ask them live at the end of the session after Ahmed has done his wonderful demo. So without further ado, I will hand over to Iulian. Are you there? Let me just.
Yes, morning.
And I will make you presenter.
Yeah, just give me one moment.
It's looking good, Iulian.
Yeah.
Thank you. Take it away.
Cool. Just give me one moment. Cool. Good morning, everyone. Thanks for joining us here today. My name is Iulian, and I am a startup solution architect at AWS. And today we're going to talk about running serverless containers on ECS. For the agenda, as Jason has mentioned, we have an introduction to Fargate and containers at AWS. Then we will follow this up with a demo by Firemind. So Ahmed will do a demo, and then we'll have some time for Q&A at the end. So when it comes to containers, AWS provides a broad set of services to suit different workloads. We have application networking like AWS Cloud Map, which is a cloud resource discovery service. We have App Mesh, which is a service mesh to monitor and control service-to-service communication. We have orchestration management, and that is ECS, which I'll go into a bit more detail, and also the EKS. When it comes to hosting options, this all depends of how much control you require over your infrastructure. And again, here we have two options, the typical EC2 and AWS Fargate. And also we have the ECR, which is the container image repository where your containers will be stored. Deploying your managed containers, as I said, we have orchestration tools like Elastic Container Services, also known as ECS, which is known for its simplicity. It's AWS own containers orchestration tool, and also Elastic Kubernetes Services, we refer to as EKS. It's an AWS managed Kubernetes service, and known for its flexibility, but not as easy to manage as ECS. In terms of choosing your compute, again, you have options. This is the one is EC2, where you're running your containers with server level control, and Fargate, where you're running containers without managing any servers. So now let's see how containers fit into the AWS ecosystem. Managing containers is not as straightforward and simple as it might seem. It's not just pulling a Docker image and deploying it. We need to deploy them, maintain them, network them, scale them, and much more. If we were to manage only a couple of these containers, it would have been relatively easy. But what if our application is continuously evolving and growing, and then we have several of tens of these containers to manage and scale? It can easily get out of control. And this is where AWS services such as Elastic Container Services and Elastic Kubernetes Services come into the picture. So ECS is a native AWS service that was purpose-built for running containerized applications into the cloud. Service discovery, routing, and load balancing are a bit more streamlined using ECS. ECS provides networking and support components via AWS service components such as application load balancers, Amazon Route 53, and Amazon CloudWatch. On the contrary, Kubernetes provides this mechanism internally. EKS, on the other hand, makes it easy to deploy, manage, and scale containerized application using Kubernetes on AWS. And EKS helps managing and scaling of your EKS master clusters. EKS offers a uniform experience between Kubernetes running on premises or elsewhere and on AWS. EKS also enables the use of a wide range of Kubernetes ecosystem add-ons like Calico, CNI, which is a sophisticated network policy engine. It integrates with Prometheus. We also have VPC CNI, a network plugin for pod networking within the AWS VPC. But you still end up managing more than just containers. And there is a lot of effort that goes into managing the infrastructure, like patching and upgrading the operating systems and the agents, and also making sure that your application is optimized in terms of scalability. So operating containers at scale come with its own challenges, as you have to take into the account the security. Are your hosts patched, and is your MEI up to date? Are your workload running efficiently? Are they properly sized? And that often means shifting your attention from building your application to maintaining the infrastructure. Here at AWS, we work backwards from the customers. We often hear from our customers, especially those without big engineering teams, that they are looking to simplify their infrastructure maintenance. So they asked us to take more so that they can concentrate on what's important to them, and that's building the application. And that's how Fargate came into place. AWS Fargate is a technology for Amazon ECS and also EKS that allows you to run containers without having to manage servers or clusters. With AWS Fargate, you no longer have to provision, configure, and scale clusters of virtual machines to run containers, and that's letting you focus on the designing and building your applications instead of managing the infrastructure that runs them. We will cover the basic of AWS Fargate and show you how to get started running containerized application and microservices on AWS with this powerful new technology. As we know, AWS works on a shared responsibility model, and owing to that, running containers on EC2 means you owing a lot of operational overhead, such as the management, patching, updating, and scalability of the underlying infrastructure. Imagine how it will be to have a solution where you don't have to worry about any of this operational overhead. And you don't have to worry about resources availability while scaling your application. How about someone else doing all of that heavy lifting for you? So we've taken over the operating system. We've taken over the overhead of the container runtime and also storage, logging, and monitoring plugins. The answer to these questions is Fargate. Fargate was introduced to reduce customer operational overhead so that they can focus more on what really matters to them, and that's their application. Fargate is a container deployment model where you don't have to manage or maintain the infrastructure hosting your containers. AWS does everything for you, from managing, updating, patching, to scaling of containers of your service. Simply put, Fargate is a serverless compute where you don't have to worry about the underlying infrastructure or how it works. You just focus on your application. So Fargate simplifies the containers experience. It's serverless, so that means no EC2 instance to provision, scale, or manage. Is elastic, and it integrates very well with AWS ecosystem like VPC networking, Elastic Load Balancer, IAM permissions, CloudWatch, and more. So yeah, I think the team is focused on your application, not on your infrastructure. We will now dive a bit more into the AWS Fargate and how it works. So when we talk about Fargate data plane, you may ask where do containers run? So they live on an EC2 instance that are not on your account. They live in a Fargate account within a Fargate VPC. VMs usually needs minutes to boot up, and in most cases, this is not acceptable for containers startup times. So what is happening under the hood? We're actually keeping a pool of pre-running EC2 instances that are already up and running. And as your task launches come, AWS is picking up an already running instance and put your task on it. When it comes to the physical server, hypervisor, guest, kernel, and OS, Fargate agent, and container runtime, we maintain the full cycle of these EC2 instances. Networking-wise, the primary network interface for this EC2 instance at 0 is actually in the Fargate VPC. So we maintain that because the instance was launched in the Fargate VPC. But when this instance gets selected to host a task, we create an elastic network interface, or ENI, in your own VPC, and then we attach it to this instance as a secondary network interface. And any network traffic that's come from the Fargate agent or any system components that's between that Fargate task and the EC2 instance line is going through the Fargate ENI through our VPC. But any network traffic that's coming from your application, including image pool and logs, it's happening through your own ENI, your VPC. This helps isolate the task from the infrastructure layer, and this also means you or any other customer will not have access to the underlying infrastructure. How do you size the task or the pod? So when it comes to the pod spec, EKS will check the amount of CPU and memory resources that are requested and adds 256 megabits of memory for Kubernetes components such as the kubelet. It looks at both init containers, which start sequentially when the pod is scheduled and then stop, and the long-running containers, which run for the lifetime of the pod and takes the higher value of the two. It then picks the closest Fargate configuration, rounding it up if necessary. It's generally considered best practice to have vCPU and memory resources request and limits in your Kubernetes spec files, as this prevents individual containers stealing all the resources on a single worker node. AWS Fargate, the serverless compute engine for the Amazon Elastic Container Service and also EKS, now enables customers to scale application faster, improving performance and reducing wait time. We have made several improvements over the last years that enables you to scale application up to 16 times faster, making it easier to build and run applications at a larger scale on Fargate. When using the Amazon ECS service scheduler for running web and other long-running applications, you will be able to launch up to 500 tasks in under 1 minute per service. And this is 16 times faster than last year. Previously, you would have to wait it for nearly 15 minutes to scale an application to 500 tasks at steady state. When running one-time or periodic batch jobs using ECS Run Task API, Fargate now allows customers' accounts to burst up to 100 on-demand or spot tasks with a sustained task launch of 20 tasks per second, again 20 times faster than last year. So let's take, for example, if you run a batch job with 1,200 on-demand tasks, you can now launch your job in under a minute, whilst previously it would have been taken around 20 minutes. And similarly, on the EKS Fargate, customers will now observe up to 20 times faster scaling when using platform versions that they've recently been released. There are, of course, some caveats. There is no spot support on the EKS for Fargate. Privileged containers are not supported. They are limited and ephemeral storage, so you can use EFS to extend your storage. And GPUs are currently not available, as well as EKS daemon sets. Fargate is secure by default. So as I mentioned before, Fargate is designed to be secure. All the containers are isolated at the hardware and network level, as explained previously in the architecture section. So the ephemeral storage is dedicated and is encrypted. The credentials stored for containers are encrypted and isolated per application. The underlying infrastructure is always patched and kept updated. Just think about it. When a new CVE is discovered, how long does it take your team today to patch all the servers? With Fargate, all this overhead is taken away from you. Amazon ECS provides monitoring capabilities for your containers and cluster through the Amazon CloudWatch. You can monitor the average and aggregate CPU and memory utilization of running tasks as grouped by task definitions, service, or cluster. You can set CloudWatch alarms to alert you when your containers or cluster need to scale up or down. Amazon ECS allows you to record all of your Amazon ECS API calls, and you can have these log files delivered to you through the AWS CloudTrail. You can do ad hoc analytics and then observability experience across metrics, logs, and traces. When it comes to purchase options, we have a few different options. We have pay on demand, so you just pay for container per second with no long-term commitment. These are good for workloads where capacity needs can change rapidly. We also have compute savings plans where you could make 1 or 3 year commitment and receive a significant discount. Or you can opt for spot pricing to run your containers with a caveat that containers might be stopped with 2 minutes notice. Usually containers are able to handle such disruption, but we need to make sure that the application is also able to handle the disruption and continue with the usual processing. One other option is you could look at distributing load between spot and on-demand to balance cost and performance. If if your workload cannot afford to have the disruption, then you could look at the compute savings plans as a better option. So you pay for what you provision. It's built at the task level vCPU and memory units, and is per second billing, with the first minute being minimum. In terms of the Fargate compute, you have different options in terms of the vCPU and memory. We've just recently added new compute options, and that is 8 vCPU, and you can go up to the 16 CPU. Being able to select EC2 Spot as a capacity provider seems like it's something you would want to do given the cost reduction, as long as your application can handle interruptions. But why are we talking about Fargate as a capacity provider? Surely by its nature, it's already a capacity provider. Well, yes, but you can also select the new option Fargate Spot, as I mentioned previously, as a capacity provider. So with Spot, this means a reduction in Fargate cost of up to 70% of standard Fargate prices. So you should choose Fargate Spot if your workload can withstand interruptions, as Fargate Spot makes use of excess capacity in an availability zones. So as I mentioned, you can combine this with a standard Fargate to ensure that you keep a base capacity whilst utilizing Spot to reduce the cost and increase the scalability of your task running. So this is for my quick presentations. Now I'm just going to hand you over to Ahmed from Firemind to demonstrate a quick demo.
Thank you, Iulian. Thank you. So yes, I just want to touch a little bit on how a lot of that stuff can seem maybe confusing, or trying to understand how the relationship works between us at Firemind, you as the customer, and AWS. So we're here to enable our customers and startups to understand what is the best way that they can use these really cool tools to help optimize cost and performance and reliability without having the full kind of headache, if that makes sense. And I've got a little demo to show you guys of how we can use these serverless tools with state management that's fully managed by AWS as well. I'm just waiting for the screen so I can share, please, Iulian.
Yeah, just give me one moment.
Ah, cool, here we go. Sweet. So I'm going to share with everyone a quick link to GitHub. Have a look at this. Go have a play. This is all the code for the demo we're talking about here today. Something we do with a lot of our customers, especially startup customers, is that they'll come along and they'll want to be, quite rightly, completely serverless. I love serverless. It works brilliantly. No one wants to manage EC2s. Exactly like Iulian said, no one wants the pain of patching stuff, having to deal with CVEs, all that kind of stuff. You just want Amazon to deal with all that guff for you, which is fine, right? That's their job. That's what they're being paid for. But one of the biggest problems, or one of the biggest concerns that a lot of startup customers share with us, is how do they deal with long-running tasks and how do they deal with decoupled state management between all these serverless workloads. So a really simple kind of idea around this is zipping stuff up. Let's say you're a startup. Let's say you have lots of data, whether it's for a customer, company, or whatever, And let's say you can't necessarily control what that data is. You want to give them an export. That data could be 10 megabytes, it could be 10 gigabytes, right? Do you want to provision an EC2 to run a zipper service? Probably not. It's not worth it. Will the zipper service always be used? Would it be used during peak times? How do you optimize this approach? So this is the example we have here. We've done this with a number of customers where they want to be serverless, but they want to provide exports, and they can't quite guarantee the size of the export. So go to that GitHub link, have a look through the source code. I'm just going to walk you through how the infrastructure works. While we're doing this as well, there is a front end that you can test, which is this as well. Apologies for the long URL, it's our dev URLs. But then you can see, if you want to look inside, the network tools, how this thing will work. It's pretty straightforward how everything kind of goes. And please, at any point, just ask a question or whatever, and I can certainly explain, the kind of thought process behind this. So again, we're thinking in a typical fashion, right? We are a startup, we are serverless, so we have a front end. That front end could be in React, could be in Angular, could be in Vue. We typically deploy it via S3 with CloudFront at the front. Maybe we add some WAF in there as well. We will have our Lambdas that run our functional API code, and that will be through API Gateway. But we can't rely on Lambda to be around long enough to zip up 10 gigabytes or 1,000 files or whatever. So this is where ECS and ECS Fargate is very powerful, because it allows us to spin up these tasks, again, either on demand, like Iulian said, whether that's with a savings plan as well. So if we know we're going to have a predictable workload, or, which we completely love, by using spot instances. And spot instances really are the champion of Fargate here, because you can save so much money by having these kind of batch process tasks. And the way this zipper works is pretty straightforward. You come to the service, or customer will come to the service. They will ask for a job to zip up their stuff, and we maintain state in two places. One is DynamoDB and one is SQS. What will happen here is Lambda will create a job for zipping up this service. It will store that job ID in DynamoDB, and it will submit it into a queue in SQS. In this example, we have our container, and the container consumes each job one at a time from SQS. When that job is done, it simply goes back to DynamoDB and it says, hey, I'm done. The magic is on the front end, and you can see this here, because what happens, and the way that we think about this, especially if you're going down the startup route, you have an Angular application or React application, we make the request receives our job to say, hey, I've accepted your job, here's your ID. And then we poll an API to say, right, has Fargate completed? And this allows the front end to provide a nice, polite loader, so the user can see actually something is ready. And as they click download, download my zip file, download my data, that's all available directly from S3. They can have a look at their data that they've downloaded, and I can say, oh, okay, here I've got my PDFs, my images, my whatever export that I have that I wanted, in a manner that may not necessarily be predictable, because customer data could change. And this is what makes it really nice about having this kind of detachment of states. You're having to think differently than just having a standard EC2 with a standard EBS storage and having everything on that machine. You decouple and you take full advantage of things like Fargate to allow you to then use spot fleeting as well. So then you can really keep this optimized. So I'll quickly run you through the code and show you how everything's working. So again, everything's here on GitHub. You can have a look. The way that we built it is all in Terraform. And I'll start from the top. So again, Amazon gives you ECR, Elastic Container Registry, where you can build your images and deploy them up for ECS to consume. This is a Node.js service. I have a very simple Docker file, so I'm using standard Node 16 Alpine. There are other images that you can use. There are custom Lambda images you can use from AWS, which is completely fine. I don't need it here. I don't need the V2 SDK, so I'm keeping this really, really simple. And again, all this Docker image is doing is just taking my code, taking any state that I want, running my npm install. npm CI is actually a bit faster. It's built for headless installations, which is a lot easier. And then it's running my
Ahmed, sorry to interrupt. Can you just zoom in just a little bit?
Yes. Oh, sorry. Apologies. I forget I'm on a massive screen. There we go.
No worries. That's
better?
perfect. Yeah, much better. Thank you.
And this is pretty standard Docker file. Again, Amazon has some pre-built images that work really well, and it's just doing exactly this, taking my source code. If we look at the source code, all it's doing, again, I'm bringing in my V3 SDK. You can use V2 if you want. V3 is nice, it's okay. And all this code is simply doing is it's just polling SQS and receiving one message at a time. That's it. We can get into the nuances of SQS and visibility timeout, another time. There's lots of documentation you can read on the toilet that certainly helps you understand this better. But the premise is still quite simple. This thing sits there, receives a single message, receives the metadata from DynamoDB. What is my prefix? What is my job ID? And I'll show you this really quickly here. The idea is that we have my S3 bucket. Hopefully everyone can see this. And in my S3 bucket, me being a customer of the startup, I have my special files, and I have my special files in my S3 buckets. And what the script will do is it will then go and take these objects. So we list them from the bucket. We receive every object. Let me just turn on word wrap for you guys. And here we're just filtering the files that we want. And then the magic of Node.js, again, you can do this in Python if you wanted, Go, whatever. We stream the files into a zip file directly from S3 back into S3. So it's very nice when we're thinking about memory management, when we're not having to worry about local storage, etc. It just comes from S3, goes straight back to S3 again. The magic of AWS, right? And then when that job is done, it simply reports back to DynamoDB that we're completed, we're ready. And that's then for the front end to pick up and say, hey, your zip file is ready. And the way that we actually download the zip file, again, to keep this nice and easy, because we're not having to have a zip file stored on a local directory somewhere in EC2 or whatever, we just use a signed URL. We generate a signed URL from S3 that brings it down for us. Bob's your uncle. Nothing has to touch compute in terms of file transfer. And then I'll show you really quickly here again. This is our S3 buckets, and in here, hopefully, you can see, several people. We've got 2 zip jobs there where the zip file has been created. We can see our task here, for example, and we can see the tasks that are running. And you can see, the logs that are running here. So we're relatively verbose in how I'm console logging everything, just for everyone to see. And again, this is all in the source code there as well. I'll just quickly run you through the Terraform to help you understand what's going on. So we have our container registry. Again, to follow best practice, to follow well-architected approaches, we have to make sure that we're using correct encryption. So we have our KMS keys. We ensure that the policy allows Fargate to use those KMS keys, here we are, to bring down our images and decrypt them, which is what we want. We have our cluster, and in our cluster here again, because we are living in 2022, we're using ARM64 because it's cheaper, it's a single-threaded process. Again, as a partner, we'll work with you and we'll work with AWS to ensure that we identify what workloads you're trying to run, how you can be as cost effective as possible. So really, you pay Amazon as little as possible. Hopefully Jason and Iulian didn't hear that, but we want to make sure this is completely cost optimized for you as the customer. And again, this is a pretty simple, small task as well. So we're not using that much CPU or memory. We have all of our network configuration set up. We have our IAM role that can then pull, do the policy attachment, etc. The general standard stuff. And also we have our task definition. So we're defining here how we want our task to run, whether we want it to run on Fargate, whether we want it to run on Spots. At the moment, this is just running on Fargate. This could easily just happen on Spots and we then build our code for that 2-minute interruption window, which again is pretty straightforward because all of our state is completely decoupled. In terms of the S3 bucket, again, we have to make sure we're building our buckets correctly. We are using rules, so expiration. So we don't need to keep these zip files after 2 days. They should just delete. And again, we can allow Amazon to deal with that for us. We're making sure we're using correct encryption as well. So we have to ensure that our service that runs on ECS has the correct permissions to get the KMS key and decrypt these objects that we're going to zip up, and then encrypt the zip file that we're then going to place on AWS for us. And that's pretty much it. We want to keep it nice and simple. We want to keep everything decoupled. We want to fully utilize all of the compute that Amazon provides for us in the cost-effective manner, and to make sure that should there be a service interruption, should the task fall over or whatever, we can pick up from where we left off, because our state is held in all these managed services as well. Cool.
Awesome. Thanks very much. That's been great. If you have any questions, do pop them in the side panel. We will go into a sort of quick Q&A session. Let me just share my screen again. Cool. I mean, if the two presenters can come up on video, and if you have any questions, please just pop them in and we can ask them live now. And in the meantime, while that's happening, one of the questions for Ahmed is, could you not just do it all with serverless?
Absolutely. You could absolutely do all of this in serverless. Technically, this all is serverless. The reason that we used the zipper idea here is because you may not know how much data you need to zip. So if it's 10 gigabytes, the 50-minute Lambda timeout may not be enough for what you're trying to do. It may not have enough memory for what you're trying to do, in which case using something like Fargate, where you can have a long-running task that could stop and start again, is much more reliable and much more cost-effective than trying to have the Lambdas that.
Awesome. I think it's, I don't know if it cut out for me.
Oh, sorry. There we
There's
go.
a lot, yeah. All right, cool. But I got the gist of it. There's another question here from Charlie. Hello. How should you manage state between serverless containers? Obviously, with the idea of containers, you want to have something that's stateless, right? So what is a good approach to manage that state? For instance, you know, you have some sort of website and you want to maintain sessions, or you want to, you know, pick up from where you left off. Maybe you're processing a large file, you don't want to reprocess everything. What is a good way to manage that state in AWS, or just in general?
Yeah, so DynamoDB is a very powerful tool. Again, if you want to maintain serverless ability, right? So DynamoDB is a really good way to think about session management, cache management, task management, right? It's very cost effective. It bursts very, very fast as well. So generally, when we speak to customers, we always kind of talk to them about how they can use DynamoDB from a simple key value store to correctly using it with indexes and secondary indexes to really be as optimal as possible. So we always go down that route. And then in terms of file state, again, EFS, incredibly powerful, S3, incredibly powerful, very cost effective and very scalable as well.
Awesome. One of the questions that I also have is, why go with ECS and not just go straight to EKS? Maybe that's something for Iulian, if you can.
Yeah, so I think it very much depends on your skills, on your in-house skills, on your engineering team. ECS, it's easier to start with, so I would recommend, if you have no containers capabilities inside your engineering team, then start with ECS. EKS, it takes a bit more time and effort, and there are a lot more dependencies that you need to manage. So yeah. in a nutshell, ECS, it's easier to start with if you have no containers capabilities.
Yeah, no, I definitely agree with that. I think I've seen a couple of cases where customers are very ambitious, but the complexity of actually managing all of those different components inside of a Kubernetes cluster can be a little bit too much. All right, so we've got a question here. I don't know if it's quite related to containers, but we can go ahead anyway. Laurent has a use case where they need to send 3 times a day. They need to send thousands of notifications using something like, well, it's push notifications, so it's using Firebase. Which service would be best for that? Maybe that's for Ahmed, if you know of anything.
I would just use Lambda. A lot of these notifications will be fire and forget. Lambda will be cheaper. If you need to send them all at the same time, then you can horizontally scale Lambda. If you don't need to send them all at the same time, chuck them in an SQS queue and then just consume each one at a time using a FIFO queue. Pretty straightforward, very, very cheap, and that will work at scale.
Yeah.
All
Yeah,
at the same time?
they also said all at the same time, yeah.
Yeah, so you could just go on, sorry.
Yeah, no, I was going to say the same. So something like, SQS driving a Lambda function. I think for the actual sort of connecting to the mobile side, I would also have a look at, we have a service called Pinpoint, which can help you manage the actual push notifications down to a mobile app. So that might be kind of, a two-part side. Once you do that sort of initial trigger, you can, for instance, there's something called Event Bridge where you can set up a scheduled event. So at a certain time it will trigger, and then that can potentially trigger your first iteration, which would take all those items and maybe load it into the queue, and then you'd have that processing off the back of that queue and triggering whatever notification system you want. Cool. The last thing I wanted to ask, and this is just for the Firemind side, is how do people get in contact if they want to engage with you further?
Absolutely. So you can either go to my Twitter or find us on LinkedIn, or just go to firemind.com, and then you can just contact us directly from there. There's a little chatbot in the corner that comes up on our Slack, and then yeah, just get in touch. And if you guys are eligible for Basecamp workshop, we come in for 2 days, work out what you're trying to do from a product point of view, and really try to help you accelerate onto the AWS cloud.
Awesome. Thank you both for the presentations.
No problem.
You can go off camera.
Thank you.
Cool. The last thing I just wanted to go over is what you can get up to next, right? So we've shown you today about containers and Fargate, but there's a lot more to offer. If you go onto the Startup Loft, the same link that you came in through this morning, what you can find is that there's a lot of different programs, a lot of different webinars out there. The two that I think are the most exciting from my perspective is the first one, which is on the 25th of October. We have Architecture Foundations, preparing for production, which is going to be a session on how you can think about getting your application. If you've started building an MVP, for instance, you might have deployed it already or looking to deploy into production at the end of the year. I know the end of the year is usually crunch time for that kind of thing. So if you want to know some of the best practices around that, and also how to be a bit more resilient to avoid things falling over. Also, there are some people out there that are preparing for things like Black Friday, Cyber Monday. So you can join that session on the 25th of October. It's also a virtual session, same thing on the Loft, where you can come and learn about how to prepare your application to be more resilient in a production environment. The second one is on the 26th of October. We've got another virtual event, which is part of the Startup Scale series. So it's a little bit more hands-on, a little bit more of a deeper dive. And it's an introduction to ML Ops and Amazon SageMaker. So if you've ever wanted to build your own models or train your own models, Amazon SageMaker is a set of tools that allow you to do that. And especially when it comes to automating all of the different components within a machine learning pipeline, it can be quite tricky. So this session is going to be for that, where you'll learn a little bit about ML Ops, how you can sort of create these pipelines using Amazon SageMaker to build, train, test, deploy your machine learning models. And then there's a couple of other links there. So what I'd usually recommend is people just take a quick screenshot of this, save it onto your hard drive for later. There's things like the Activate program, which is now you can get access to the Activate console just directly from the AWS console without necessarily needing to be part of Activate. There's a few special offers over there. There's also things happening on a Clubhouse with our startup advocate, Mark Birch. We've got Twitter, Twitch, a whole bunch of stuff on YouTube, and a lot of stuff on the Startup Loft in terms of resources, webinars, and especially one feature is Ask the Expert. So if you wanted to go book a one-on-one session with one of our startup experts, you can go do that on the Loft right now. So that's it from me. That's it from Ahmed and Iulian. Thanks for the speakers. Thank you for presenting today. Hopefully you've enjoyed the session. If you have, please just wait a little bit. There will be a little bit of a feedback thing that pops up. It'd be good to get the feedback. I did see the comments about having a pinpoint session. Yeah, maybe we can organize that, Laurent. So yes, we do try and bring in the feedback. If you can just fill in that little prompt. And yeah, hopefully we'll see you next time. Thank you and have a good day.